Hello everyone and welcome back to CFDverse, your own multiverse for the CFD studies. So today we are going to perform CFD analysis of a mixing tank. So what we will be doing is first of all, this first step is geometry creation. We'll be importing a 3D model of the tank blades and we will be easing up the geometry. We can say we are cleaning up the geometry for our own use. Then we will be defining one vessel size and we will be extracting the volume from that vessel. Then, in order to mix the fluids, we will require one rotary domain, which we will be using as a prop, which we can rotate in the fluid. After that, the second step is meshing. In the meshing, we will be using the optimized mesh, which will be enough to generate a good mesh size with the skewness and the orthogonal qualities. And we will be using inflation layers, which will accurately capture the boundary layers. The third step is the simulation setup. So we are going to solve the steady state problem. We'll be using water for the mixing purpose. And as a turbulence model, we will be using K epsilon enhanced fault treatment model. Next step is to rotate the blades. So in order to rotate the blades, we'll be using frame motion. So I'll be teaching you how to use the frame motion as output. So when we will get the results, we will want to see that how our mixing has happened. In order to judge that, we will be doing and we will be learning pressure on blades, then the velocity contours, vectors, and animations. So here is the geometry for our today's simulation. This geometry I have taken from GraphCAD and I will be linking this geometry in the description. So first of all, in this geometry, we won't be needing this motor. So I will be deleting this part. Then you can see this bottom part is also not required. I have deleted it. Now you can see these are the chamfers. So the any extra portions which are not required in our simulations, we will be removing. It helps in reducing the mesh size and also it is important to perform this operation in order to remove the unnecessary details. So I will be selecting all the geometries and I will combine them. Once combined, you can see this is the one body. So now I will see that I will move the geometry to the origin. So I will select the geometry. I will press move. I will select the anchor. So my anchor location will be the center of this geometry. So I will click on here. So you can see at the center, the geometry has been shifted. Now I will use this arrow and I will click up to. So in the up to operation, I will select up to the origin. Once I have done that, you can see the geometry center has been shifted to center of these blades. Why I have done this operation is because I want to create a rotary domain, and when I create the rotary domain, my geometry will revolve around this center. Now you can see the length of this center shaft. I don't want my center shaft to be this much of the length because I am solving the small problem. I will reduce its length. So I will create first a plane on the top of this rod. Okay. I will choose the front view from the x-axis. Then I will move this plane downside. Okay. So I guess this will be the sufficient height. Then I will use the split command. I will split this whole geometry and cutter will be my plane. And the remaining top of the shaft I will remove. Now you can see this much of the geometry I am going to use. So I have not removed any chamfers or the shapes of this blade because these are the parts of the blades which will be used in the mixing also. So I don't want to ruin that geometry. Okay. I have simplified the geometry other than blades. Now I have to create one tank. So I will use K of K, which is used for sketching. I will generate one vessel. So in order to make the vessel, I need to create one circle. The circle's diameter, I can take like I will go with 350 mm as a diameter. Okay, and I will again go and choose as 370 mm as its external diameter. Once this is done, I will pull this created geometry and up to I will create bottom of these blades. But if you see from the side view, blades are at the bottom of this. So I will again create one plane at the bottom. Okay. I have deleted all the planes. I will create a new plane at the bottom of this geometry. Then I will move that plane in downward direction up to 100 mm, but it is too high, so I will reduce it to 25 mm. Yeah, this seems right. Now I will again sketch one small circle here. Suppose 325 mm as a dia, and its external dia as 340 mm. I will exit the sketch, and now I will use this surface and this newly created surface, and I will use blend option. So while blending, I will be using rotational blend, or I can use ruled segment. So ruled segment will give you the geometry like this. So I guess ruled segment is fine. Now as you can see, now I have to extract the volume. To extract the volume, I will go to prepare tab. I will use volume extract option. So you have to select faces that encloses the region. So I will be selecting this face, and the next one is my bottom face. Then I will be using seed phase. So seed phase is the volume from which the spacelem starts creating the volume. It requires that seed phase. I will choose inside phase, and I will click on this tick mark. So once done, I will be getting this volume. Now I have suppressed the vessel because my operation of extracting the volume from the vessel is complete. If you want to see the inside view, you just click on this axis and press X. You can see the volume has been extracted, and this is our blade geometry. I will hide this volume. I have seen something inside this tube, so okay, I will remove it further. Now the task is to create a rotary domain around these blades. In order to do that, I will create a plane here. I will perform a sketch operation. I have selected one circle. Now the diameter of circle should be such that it should be close to the blades. Okay. So if you see, this is diameter of the blade. So it should be close to the blade. So I have chosen 306 as my die. Now as my circle is interfering with the blades. I want it to be slightly away from the blades. So I'll be keeping it, you can say minus 10 mm. So if I see from the side, yeah, it looks good. Again, I will perform the same operation. I will be moving that blade. Sorry, I will be moving that surface and I will be keeping its distance. I will select this ruler and from the bottom of blade, I will keep its distance as a 10 mm. Right? So it's same now. I will be performing pull operation. While pulling, just remember that to click this no merge operation and I will be doing up to. So it will create one domain. When you view from the side and by clicking X, you will be seeing section view. Here you can see both geometries are interfering now. So for that reason, I will require to use interference. So here the interference region is found. So if you directly click on the tick mark, it will remove the blade geometry. So you have to click on subtract from the smaller body. When you do that, you can make it transparent and you can see that blade geometry had all suppressed and I take the section view. So you can see that my rotary domain and the volume of fluid are interfering. So they should not interfere. So first of all, I will hide the blade. Okay. I will make it transparent for easier to view. Okay. And now I will again click on interference. So once this is completed, now you can see there are three fluids or two. There are two fluids. One fluid which is the rotary domain, one is the stationary domain, and this one is the wall, which are our mixing blades. Now we have to give them the names. First of all, I will give this fluid name as the stationary domain. I will hide it. I will give this fluid the name as a rotary domain. And now this blade is also not required. I will suppress it. One step is remaining, which is share topology. So we will be performing share topology operation. Now we will be moving to the meshing operation. So here you can see we have imported our geometry. For the local sizing, I won't be adding any local sizing. So we will be choosing option as a no and click on update. After that, in the generates the surface mesh, the fluent machine has suggested us the minimum size as a 0.45 and maximum as the 11.60. So I will be reducing my minimum size as a 0.4 and I will be choosing maximum size as 10. Okay. Now in our geometry we have the curved surfaces. This fluid region is the circular section and again our rotary domain is also the circular section. In order to capture much better details, we are using curvature normal angle as a 15 degree and we are going to use the cells per gap as 2. One thing we have to remember while doing the surface mesh is that skewness quality. Our skewness quality should be lower than 0.7. So here I have directly obtained the quality as a 0.69. If your quality is above zero point 0.7, then you should right click here and insert improve surface mesh operation. I won't be doing that operation right now as I have already achieved the quality. In the discrete geometry section, you can see that there are few options. In my geometry, the geometry consists only fluid regions. So I have selected these options, and we have already shared in the space claim, so we won't be doing that again. Then as our rotary domain and our stationary domain, both will be working as a wall. So I will update the boundaries. In the region section, you can see both of our domains are taken as the fluid domain, which is correct. Hence, we will be updating the region. Now in the boundary layer sections, number of layers as per my suggestion would be that we will be using 5 number of layers. For the volume mesh, I have using polyhexco mesh, and I click on generate the volume mesh button. For the volume mesh, you have to remember that our orthogonal quality should be 0.15 as a minimum factor. If it is below 0.15, then you have to improve the volume mesh. And on the other side, if it is above the 0.15, then it's good. As you can see, our minimum orthogonal quality is 0.12. So we need to improve this quality. I will be adding insert new task, which is improve volume mesh. If I choose 0.2 here, I will see how much it improves. So when I click on improve volume mesh, Fluent Meshing will try to improve the volume mesh quality up to 0.2. As you can see, my final quality is 0.2. So we are done with the meshing part. Now we'll be going ahead with the setup. Here we are in the setup of the Fluent. We'll be taking gravity in the negative y direction. So it will be minus 9.81. We are going to use pressure based and steady state solver. Then in the model, we don't have any heat transfer or temperature related problem here. In the viscous, we are going to use K epsilon model, which is realizable K epsilon with enhanced ball treatment. Next step is choosing the material. So in the fluid section, we have to choose a new material. We will go to Fluent database and we will choose water liquid, copy, close. Here you can see the water liquid has been added. The solid part is aluminum, which is not required to us. In the cell zone, we have to assign rotary domain and the stationary domain, both a material which is water. Once this is done, in the boundary conditions, we have internal and the walls. Here there is no inlet or outlet because the fluid will be mixing on its own using the blades. So I will show you now the rotary domain part. To visualize that in which direction our fluid is going to rotate, we'll be seeing the top view. In display tab, we'll select rotary domain. You will be seeing these blades from the top view. So if you can imagine that my blades will rotate in anti-clockwise direction. Hence, in the rotary domain, we are going to use this frame motion option where we will be giving rotation axis direction. So now it is Z. Our rotation axis is Y as it will be revolving in the anticlockwise direction around Y. So I am going with the 1 here. Okay. And for the speed, it is in the radian per second right now. So I'll be going with angular velocity. Yeah, here it is. So I will choose revolutions per minute. And RPM, let's suppose for this example, we are going to use 100 RPM. So I'll click on apply, close. Now our rotary domain is set to revolve at 100 RPM. In the methods tab, we are going to use coupled method. Then in the monitors tab, we will be reducing our residuals. Now the next step is in the wall. These are our blades. There is another wall which we are going to see, which is this, which is rotary domain and stationary domains common wall. If I keep this stationary and rotary domain common interface as a wall, then fluid will revolve inside the domain only. It won't interact with the stationary domain. Hence, I have to select the type and I have to change it to the interior. Once this is done, we will initialize. Now you can see that hybrid initialization is done. Now, in order to visualize our results, we will create some surfaces. We will create one contour which is for velocity and it will be on this plane. Okay, so if I take the front view, you can see I will change the number format to float. Now, as you can see, this is our rotating domain and fluid is rotating in this region. Now I have to make one animation. In order to make animation, we have to go to calculation activities, click on solution animations. I will updating my animation every 5 iterations and I am using contour 1 as an animation object. If I click in use active, it will select this view as a permanent view to record my animations. I will click on OK and I will also auto save my iterations every 5 iterations. Now I will calculate my solution for 200 iterations. So after 200 iterations, we have stopped the simulation. We won't be running it further. But I would like to tell you that the pattern of the mixing is not yet constant. So you will need to run it for at least 600 to 700 iterations. Now I will be showing you the animation. So we are going to the animations option, playback, and when you click on this playback, this is the play button. So if I click play, you can see how the mixing happens. Okay. So the number of steps I have written, which is I have written the animation after 5 iterations. Hence I am getting this written. Okay. Now we will be seeing the contours at different levels. So for the rotary domain, stationary domain, which is for rotary domain, which is our so yeah. So these are the fan blades. Okay. So let's show you from the top view. These are our fan blades which are rotating, and you can see the maximum velocity is at the tip of the blades. If you see the pressure, you can see that due to the rotation of the blades, the maximum pressure is on the top of the blade, which is around 1000 pascal, and at the bottom of the blades, the pressure is around 300 pascal, and as we go to the center, it will be negative or very close to the zero. Okay. Now we'll display our whole geometry. We'll create some additional planes, which would be at some different levels. Okay. If I take the side view, one will be at the bottom, one will be at the center, another one will put it in between. I will choose all the planes and I will choose velocity. Okay. So here if you see how mixing is happening and how the fluid is rotating, you can visualize that using various planes. Okay. If you want to calculate the velocity of the mixing fluid at a particular point, you can calculate using this. Now, if I want to create one vector, I will create it at the newly created planes. I guess this is the one. Okay, yeah, this is the one. So you have to go in vector options. You have to select in plane and fixed plane. It will create each vector of the same length. Then you have to reduce this scale to 0.01. Now you can see the pattern. Here you can see how the fluid is rotating in your domain. Okay. Direction of the rotation of the fluid. Here you can see the density of the vectors is high, which defines our boundary layers. Okay, so our rotary domain is still this area. Here there are boundary layers created. Now I will be showing you path lines. I will create them on plane 4. And I will give the steps as 200 for the start. If I click on save and display, these are the path lines we are getting. I will reduce it to the 100. I will be using single as the option. I will click on pulse. So when you click on pulse, you will be seeing the tracking of the particle variables. Okay. Yeah. So from the plane, vertical plane we have created, The particles will be generated and they will be showing us the path they have been tracking while mixing. You can see how the fluid is mixing and how it will be tracked. I will stop it and I will use another plane. When I click save and display, we are going to view that the particles will be generated from the horizontal plane and they will be tracked after that. Okay. I will be keeping it in the 3D view to understand it better. I will click on pulse. Here you can see how the mixing happens. That will give you the better idea of the mixing process. If you have any doubts, please comment. I will try to solve them. Or if you want any specific tutorial on specific topics, please let me know. I have mentioned my contact. Thank you for watching. Happy simulating.